Okay guys, so this is Unit 4, Video 2 on tension and compression. It's the last notes in your packet, okay, the last like page or two, okay? So mostly this video is going to be examples. The ideas are fairly quick to get through, but we're talking about objects that are experiencing compression and tension forces. There's also another force that we'll talk about when we talk about your bridges, which is called a torsion force or a twisting force. But these are the two we're focused on today, is the pulling force of tension and the compression, which is the pushing force. Okay, so a couple things to remember here. An object at rest experiences a net force of 0. This is a big key for this part. And the main forces on structures are tension, compression, and torsion. Okay. So an object in equilibrium, this is a new key term for us, an object in equilibrium has equal forces in all directions. So what that means is that the net force in y is 0 and the net force in x is 0. And this is the main component of these problems. All of the tension and compression problems will be in equilibrium because the object won't be moving. So the y forces are going to balance and the x forces are going to balance. Okay, so we'll go through this example. Okay, first thing you're going to do, and here's some steps, is to solve for Fg. You always want to find the weight of the object first. Okay, so if the object is 55 kilograms, 55 times 9.8 is 539 newtons. Okay, so this is 539 in the downward direction. Okay, try to focus this a little better. All right, we're going to make an F-net equation in the y-axis. So the Fg down equals the two pieces that are up. So if you look at these two tension forces, so these are both pulling up and outward, right? So if you break these into their two components, you have the y piece and the x piece. And then the y piece and the x piece. Sorry, that piece there is the x. So if you look at this picture and you were to make an F-net equation in the y, the up forces would be, and I'm going to actually call this Ty1, which is up, Ty2 is up, and Fg is down. So we're going to subtract Fg. So up, up, down. Okay. Now this is 0. And so if you were to actually move the Fg to the other side, you'd see that Ty1 plus Ty2 equals Fg. Okay, which basically means the up forces equal the down forces. Okay, and in all these problems, I'm actually going to make you an equation. The up forces equal the down forces, and the right forces equal the left forces. And this is true for all tension and compression problems. Okay. Second step, you're not going to solve this because you can't. Okay. Second step is to make an F-net equation in the x-axis. So F-net x equals right. So x2, and I'm actually going to call it tx2 and tx1. So tx2 points right, tx1 points left. That's why I subtract it. Okay. And since this is 0, since this object is not moving left or right, this will be 0. And so you'll hopefully see that tx2 equals tx1. Okay? Now, here's where it gets tricky. We have to do some math. We have too many variables. We've got 5 variables. That's too many. We need to get down to 2 variables since we have 2 equations. So what we're going to do is we're going to write tx2 in terms of t2, tx1 in terms of t1, ty1 in terms of t1, and ty2 in terms of t2. So over here, I'm going to do that. So I'm going to say tx1 equals, and if I look at this triangle, that's the cosine, right, adjacent, equals t1 cosine 50. Okay, I'm going to say ty1, which is this one, is t1 sine 50. Okay, I'm going to do the same thing for t2. I'm going to say tx2 equals t2 cosine 40, and ty2 equals t2 sine 40. Okay, those are very important. Now that I have those, I'm going to substitute them into my equations. okay? This gets very mathy. The physics was done the second we have these equations, and then the math comes in. I'm going to zoom out a little bit here, okay? So tx2 is equal to t2 cosine 40. tx1 is t1 cosine 50, okay? Same thing over here. So ty1 is t1 sine 50. ty2 is t2 sine 40. And we know fg is 539. Okay? So now we have two equations and only two unknowns, t2 and t1. That's what we want. In math, you would solve one of the equations for one of the variables and then substitute. So it's always easier to do it with the x direction. So I'm going to actually just solve for t2 here. So I'm going to say t2 equals t1 cos 50 divided by cos 40. And then I'm going to plug that in my calculator because this is just messy and I want one number. So cos 50 divided by cos 40. And I get 0.84. So t2 equals 0.84 t1. Okay? Now I'm going to take that and I'm going to sub it in for t2 over here. So I have t1 sine 50 plus t2, but t2 is not going to be t2. It's going to be 0.84 t1 sine 40. Don't forget that sine 40 equals 539. Okay? Now I have one equation, one variable. So I'm going to actually solve what sine 50 is. So sine 50 is 0.77. So t1, 0.77 t1 plus 0.84 times sine 40. So 0.54 t1 equals 539. Okay? And now we just have an algebra equation. These are like terms, so I'm going to add 0.77 plus 0.54. And I get 1.31 t1 equals 539. Divide 539 by 1.31, and I get t1 equals 411 newtons. Yay! The goal is to find t1 and t2. I have t1. Now, once you find t1, the hard part's done. You have t1, so just plug it into the equation you created. t2 equals 0.84 times t1, which is 411. So t2 equals 345. And I'm done. Now, it's a lot of math. I get it, but it's very repetitive because they're almost all the same. Okay? So that's your first example. We'll go ahead and go through a couple more here. I would just want to point out some main details. I'm not going to do all of them, but I want to point out some main details here, and then you can go ahead and finish them, okay? So for number 1, the key here is that these angles are the same, which means that the ty1, ty2, right, tx1, tx2, those pieces are actually equal because the angle is the same. So t1 and t2 are equal. That's the key about this one. And that makes this problem a lot easier. Okay, the FG is 25 times 9.8, which is 245. And so when you set this up in the, I'm going to go ahead and set it up here. So xnet, I'm going to do the x direction, so fnet, and the x equals tx2 minus tx1. Okay, and in the y direction, fnet y equals ty1 plus ty2 minus fg. Okay, but when I solve for these, so tx1 equals t1 cosine 40, right, and tx2 from over here equals t2 cosine 40. Right? And so you'll find that when you plug these in, t1 equals t2. So when we do the y direction, That's what this will tell you. Ty1 equals T1 sine 40. Ty2 equals T2 sine 40. So this equation becomes T1 cos 40 equals T2 cos 40. And if you divide by cos 40, you get T1 equals T2, right? So then over here, you have T1 sine 40 plus T2 sine 40 minus 245 equals 245. Well, T1 equals T2, so you can do T1 sine 40 plus, and then sub in T1 for T2, T1 sine 40. And now you just add sine 40 plus sine 40. So sine 40 is 0.64, so I'm going to multiply that by 2. So it's 1.29. T1 equals 245. Divide 245, and you get T1 equals 190. And then since T2 is equal to that, you can just write down that T2 also equals 190, and now that one's done. Okay, so that's the key about those being equal. It makes the problem a little bit easier. For this one, I'm going to let you guys go ahead and do this one on your own, or we can talk about it in class, but the key is this part, that these are connected. T3, if you were to cut T3, the only mass that would fall would be this one, looks like, we're just going to say that's a 10 kilogram mass, not 1, okay? So the only mass that would fall is the 10 kilogram mass, so that means that this force gravity, right, of just this mass is 98, which means that T3 is 98, okay, because it's only holding that mass, all right? Now, T1 and T2 are holding both, right? If I chop this, they both fall. If I chop this, they both fall. So once you've got T3 done, then just make it a new problem where the angles stay the same. That's still 50, but this is 35. And so then this is just 35 times. So the F gravity would be 343. Okay, and then you solve it just like we did the first example, just with these combined. Okay, hopefully that makes sense. We can talk more about that one in class. The compression problems are pretty much the same. I don't want to drag this video out too long, but compression problems are pretty much the same, except that there's a force up here pushing down on this structure. So we still have these, and they should actually be called C1 and C2, but that's okay. We still have these forces. They still have a y component each, and they still have an x component each. They're just pointing in opposite directions, the x ones. So you still have they're both equal. So this one's going to be just like this one. This one's going to be just like this one. Let me just show you how to set up the x and y stuff, but they're the same thing, and we can go over these in class. So we'll do this one. So x direction, we have F net in the x equals, and we'll call this one T2x and this one T1x. So we have T1x minus T2x, right? Okay. And we know that's 0, so that means that T1x equals T2x. Okay. And then in the y direction, we have F net y equals up forces. So the up forces are the T2y and T1y, and the down forces are the 5,000 newtons. Okay. And then we follow the exact same thing we did before. We got to go Tx or T1x equals, let's see, T1 cosine 55. T2x equals T2 cosine 55. Okay. T1y equals T1 sine 55. And T2y equals T2 sine 55. And then you'll plug those in to these 4 spots, right? And this becomes 0, so this is T2y plus T1y equals 5,000. Okay, but you plug these in, and essentially because these angles are the same, again, what's going to happen is you're going to have T1 cos 55, T2 cos 55, the cosines are going to cancel and you're going to have T1 equals T2. Okay, so then in the y direction you have T2 sine 55 plus T1 sine 55 is 5,000. If I sub in T1 for T2, sine 55 plus sine 55 is 1.64. 5,000 divided by that is T1 equals 3049 newtons. And since we know that T1 equals T2, then we can say T2 also equals 3049 newtons. And that one's done. Okay? This one you do the exact same way, okay, except that this is not going to be true, so there's going to be an extra cosine something over here that you'll have to plug in. So exactly the same way that I did the first example for you. Okay, so why don't you go ahead and just try these two on your own, the rest of this one and then this one, and then we'll go ahead and talk about any questions you have when we get to class. We'll do a different example in class. Actually, why don't you draw it maybe on the back, but we're going to do one that looks like this. Okay, where this angle is, let's say, I don't know, 60 degrees, okay? And this will be T2, all right? And let's make this a mass of, I don't know, 40 kilograms, okay? So we'll do this example in class. Just draw it on the back of your sheet, and we'll go ahead and do that first thing, because it's a little bit tricky with this one being horizontal, okay? It's actually easy, but it's a little bit tricky at first. Okay, that's it. Enjoy the rest of your weekend, and I'll see you guys on, I don't know, whenever, next Brown Day.